We have here another example of finding the inverse function, except this time it's given a graph. If you like, you can think about this as a table of points, right, where there's a whole lot of points, and they're plotted on a xy coordinate plane. But what I want to do is think about this more graphically. Remember, if you switch x and y, that's going to tell you where the point is located on the inverse of the function. So I have my functions in blue. Okay, apologies to anyone who is colorblind. This might be a little rough, but in blue I have a coordinate point. For this example, let's take the top left graph. See that point? It's at x equals 2 point something, y equals 4. Well, if you switch those points, you're going to get something like this. X is going to be equal 4, and y will be equal to 2 point something. See how that point's going to move over there if you switch x, y? The inverse, which is red, should be crossing through that point, and yet it doesn't. So what that means is that first top left graph is not a good option. Likewise over here, see how this point, if I use the same one, x equals a little more than 2, y equals 4, it should be going over here when I switch the x and y coordinates. And it's not, so there's another one that we lost. What I'm doing here, when I draw that arrow from one point to another, is I'm finding where the inverse is predicted to be. Now, let's go down here to the one where it actually exists. There's the point, same as I drew before, and here's where it should exist, right there. See, this time, the red curve is going through that point. And you can maybe not stop at just one success. Maybe we should try a few points, like this one down here. Okay, x equals -3, y equals -1 point something. If I switch those coordinates around, I get y equals -3, x equals -1 point something. See, that worked also. So this one is the inverse, and I just want to point out something very special about the inverse of a graph, or the inverse of a function. If we get rid of the little dots in here, I want to draw you a line. Okay, see this thing I'm drawing? It's called y equals x. Any function which has an inverse is going to look symmetric about that line. Notice how it's like there's a mirror image of the blue function in red, and it's flipped diagonally around this line. This is the line of symmetry for a function and its inverse. A function will always flip around the line y equals x to produce the inverse of that function. So you can go point by point if you want to do it that way. In cases where it's a little confusing to look at the graph, maybe that's better. But if you see one of these things jump out at you like, hey, that's symmetric around y equals x, bingo, that's your inverse right there.